Hi everybody, today we are learning about the Cartesian equation of a line. So last class we learned about the vector and parametric equations, and now we're learning about the Cartesian equation. So the equation of a line in slope y-intercept form from grade 9 is y equals mx plus b. The Cartesian equation, which we've in the past called standard form, is ax plus by plus c, so equals 0. So that's what we're learning more about today and its significance on the Cartesian plane. The vector equation is here, and that's what we learned yesterday. So they all kind of share something in common, and that would be the concept of slope. Okay, so slope is m in slope y-intercept form, and we can think about the direction vector as representing slope in the vector equation. So if you do have a vector, the direction vector m, and its coordinates are a, b, and if you knew that direction vector, you could find rise over run would just be rise, b, divided by a, run. Okay, so if you know the coordinates of the direction vector, we can think about this as a being the run and b being the rise. So we can use the direction vector to find slope, or we can use slope to come up with a direction vector. Now, if a equals 0, that just means the line is vertical, because think about it, that would mean the coordinate would be an x coordinate of 0, and then whatever the y coordinate is, right? So that would mean if the direction vector is there, then you're dealing with a vertical line. So their slope is undefined. So for example, determine the vector and parametric equations of this equation. So the slope here is 3 over 4. So that means that the direction vector, okay, remember this is rise over run, so it would be 4, 3, right? To get, so run is the x value, rise is the y value. And then we can use our known point that we need for the vector equation. We can use the y-intercept as that point. So therefore, the equation of the line, the vector equation would be 0, 2 plus t times 4, 3, where t is in the set of all real numbers. Okay, so what about if we have a vector equation and we want to put it into slope y-intercept form? Well, here we can see that our direction vector is -1, -4. So the slope is the rise, so the -4 over the run, sorry, the -4 over the run, so just 4. Okay, and we can think about what that looks like, right? If you go over 1 and up 4, draw a line there, the slope of that line would be 4. So we know that our equation would be y equals 4x plus b. Okay, so we need to find b, and we can use this known coordinate to do so. So -6 equals 4 times 3 plus b. We solve for b, and we get -18. So y equals 4x minus 18 is, oh, it's a terrible circle, is that equation in slope y-intercept form. Okay, now what about the Cartesian equation? Okay, well, notice here that this is a vertical line, or if we try to find the slope, we would get 2 divided by 0, so therefore it's a vertical line. So if you remember, vertical lines are just of the form x equals. So in this case, x would have to be equal to 1, since the point is 1, 4. Okay, to visualize this, you can draw it. So you know that the point 1, 4 is on the line, and you know that the direction vector is 0, 2. Okay, so it's parallel to this line, it goes to this point, so this must be the line. Okay, so now we're going to get into a very important concept of normal vectors. So this will be very instrumental over the next, this unit and the next. So if we have a line L, the line perpendicular to L that goes through the origin is called the normal. So it's not just any perpendicular vector, okay? It's specifically one that goes through the origin. So if this is our line here, we'll call it L1, then a normal, oh guys, you guys better get out your rulers. I'm gonna do my best here. Sorry, the direction vector would be parallel to this line. Okay, that would be your M. Okay, and your normal, a different color. Your normal is then perpendicular to the direction vector and perpendicular to the line. Okay, so then we can also determine some other information. Okay, so if we have a known point on the line and we have a general point there, then the direction vector, the direction vector can be determined by x minus xo and y minus yo. Okay, so this is just PO to P, right? So that's how we can determine the position vector POP is the same as the direction vector. All right, so this is, we can call this the normal. All right, so we know that the normal, I'm just developing a formula for you now. So we know that the normal dotted with the direction vector has to be 0, since by definition they are at right angles. So we're going to call the normal A, B, the coordinates of the normal, okay? Capital A, capital B. So we know that AB dotted with x minus xo and y minus yo has to equal 0. So I'm just going to separate this. So therefore, we know that ax minus axo plus by minus byo has to equal 0. Now we can rearrange this to say that ax plus by plus, and then I'm going to put in brackets, minus axo minus byo equals 0. So we're going to conclude then that ax plus by plus c equals 0, where we just let c be equal to negative axo minus byo. Okay, so why are we doing that? Why are we sectioning off axo and byo together and leaving ax and by separate and creating a constant c? Well, remember, xo and yo are given points, so they're coordinates that we know. As well, x and y are just general coordinates. So we're saying that when you multiply those known coordinates by a and b, you get just a constant c. So this is a proof to show you that when you have the Cartesian equation of a line, that the A and the B are actually the normal to that line. Okay, so let me say that again. If you know A and B, then you know the normal is, those are the coordinates of the normal. Or if you know the coordinates of the normal, you can use that to come up with the Cartesian equation of the line. Okay, so the normal vector can be found from any Cartesian equation, and we also can say the Cartesian equation can be found giving the normal and a point. So let's remember that the slopes of perpendicular lines are negative reciprocals. So if we have a line with the slope of 3/4, that means that its perpendicular is minus 4/3. So therefore, the direction vector would be 3, but the normal would be 3, -4. Now, I should use this moment to tell you guys there are infinite collinear normals, just as there are infinite collinear direction vectors. Okay, so determine the Cartesian equation of a line passing through A for -2 with a normal of 5, 3. So what does this look like? Well, if our normal is 5, 3, Okay, so there is our normal. And it passes through 4, -2. So our line then must be one that goes through this point and is perpendicular to the normal. So basically this is the line that we are attempting to find. So how can we do that? So think about it. If the normal is AB, then we know that AX plus BY plus C equals 0. And we can just sub in 5 for A, 5X, and 3 for B. So now we need to find C because it's a number in the equation. So we sub in for -2 for X and Y, and then we can solve for C. So 5 times 4 plus 3 times -2 plus C equals 0. So when you solve for this, you get C equals -14. So therefore, the equation of this line would be 5X plus 3Y minus 14 equals 0. Okay. One last thing to discuss is parallel and perpendicular lines. So normals are, if they're parallel to each other, if two lines are parallel to each other, that means the normals will be scalar multiples. Okay, so if this is line 1 and line 2, then this could be normal for 1. Okay, so it's perpendicular here, and this would be normal 2. So these green ones, oh, sorry, I don't know why it's doing that. These green ones are vectors, okay? So they start from the origin and come down and up. So that means that normals are scalar multiples of each other, and the direction vectors are scalar multiples of each other. Similarly, if two lines are perpendicular to each other, then that means their normals will be perpendicular to each other, while also being perpendicular to the line. So the dot product of the normals will be 0, and the dot product of the direction vectors will be 0. So please now take a moment to go to page 442 in your textbook and try the investigation. Thanks for watching, guys. Hope you learned lots.